The second learning objective in section 6.5 is to interpret output from a statistical program and/or calculator to carry out a regression analysis, for example, GeoGebra. 16 college student volunteers each drank a randomly assigned number of cans of beer. 30 minutes later, a police officer measured their blood alcohol content in grams of alcohol per deciliter of blood. The scatter plot and regression table summarize the findings. Do the data provide evidence that drinking more cans of beer is associated with an increase in blood alcohol content? Justify your answer using the statistical evidence and a significance level of 0.01. We can see from the scatter plot that there appears to be a positive linear relationship between cans of beer as our explanatory variable and blood alcohol content as our response variable. You can see this upward trend in the scatter plot. It looks to be pretty strong from the scatter plot, but we want to use an actual statistical test to determine whether this is a statistically significant relationship or not. If we are given computer output from a statistical software program, we'll find the test statistic and the p-value from the second row of computer output. It sometimes lists the word slope, or it'll list the name of the explanatory variable. In this case, it has beers, which is our explanatory variable, the number of cans of beers that these college student volunteers drank. The test statistic and the p-value then are given on that row right here. The t-value is the test statistic and the p-value is listed right next to it. In this case, our p-value is 0.0000. That is a very small p-value. And so our conclusion would be something like, since the p-value 0 is less than alpha equals 0.01, there is sufficient evidence to conclude that there is a significant linear relationship between number of cans of beer drunk and BAC. In fact, we can conclude, because it is an upward slope, that drinking more cans of beer is associated with an increase in blood alcohol content. Here's a second example. This one uses our GeoGebra app that is in our Canvas courses. A manager at Walmart wishes to determine the relationship between the number of years her sales representatives have been employed by Walmart and their amount of sales in thousands of dollars per month. She obtains the following output from GeoGebra. What is the test statistic for testing H0 beta 1 equals 0 versus HA beta 1 is not equal to 0? The values for the test statistic and p-value are listed right here. So our test statistic is t equals 2.16 and our p-value is 0.07. Using alpha equals 0.05, what is the correct decision about the null hypothesis? (0.07) is greater than 0.05, and so therefore we would fail to reject the null hypothesis. Based on your answer to part 3, is there a significant linear relationship between years of employment and monthly sales for all Walmart sales representatives? Since we did not reject the null hypothesis that the slope is equal to 0, in other words, that there's not a linear relationship, then no, there is not significant evidence or sufficient evidence to say that there's a significant linear relationship between these two variables.